Welcome, this is Team G2G's second presentation on the greenhouse turbine generator. The team members are Brad Fitz, Kasdan Hall, Brennan Hallows, and Jacob Solwer. Our team mentor is Dr. Keith Holbert.
Finding new ways to generate clean and sustainable electricity is an essential part of the power generation industry, especially as environmental concerns continue to grow. According to the U.S. Environmental Protection Agency, the electricity industry produces more greenhouse gases than any other sector. Options to lower greenhouse gases produced by electricity generation include increasing the efficiency of existing power plants, reducing energy demand on the consumer end, or finding new renewable power resources. A greenhouse turbine generator provides clean and renewable power, which would help in reducing greenhouse gases emissions in the electricity generation industry. A greenhouse turbine generator uses the sun's energy to heat air within a collector, which will force that air to rise up a tower and spin a turbine to produce electricity. There have been several prototype test generators built that have proven the concept, but the efficiency and cost of these generators has been a hurdle for using in industry. To make a greenhouse turbine generator a viable option for power generation, it would be required to increase the efficiency or dramatically decrease the cost and size of the generator. By experimenting with the position of the turbine within the generator's tower, it is believed that the optimum position could be found to increase the efficiency of the generator. Team GTG proposes to build a small-scale greenhouse turbine generator using available materials such as PVC, polyethylene sheeting, and a DC motor as the turbine generator. The turbine will be repositioned and tested along different points within the tower. Power output will be calculated at each of these points to determine the most efficient and beneficial location for the turbine within the tower. The greenhouse turbine generator will be built on a budget of approximately $100 and will be implemented in two phases. The first phase will be building the greenhouse turbine generator in a time frame of approximately 4 to 6 weeks. The second phase is the testing phase, which will take approximately 2 to 4 weeks depending on weather conditions. Determining the optimum location of the turbine within the tower will provide a design spec that will increase the efficiency of a greenhouse turbine generator. By increasing the efficiency of the generator, it will bring this technology one step closer to becoming a viable option on a mass scale.
A greenhouse turbine generator uses the power of the sun to heat the inside of the greenhouse. This greenhouse is known as the collector area. The air inside the collector is then heated up and it naturally rises to the top of a tower in the center of the collector due to the buoyancy effect. A turbine placed inside the tower will then be used to power a generator. The problem that our group and previous attempts have faced is how to increase the efficiency in order to make it cost effective to build. As it stands, previous designs only had efficiency in the 1 to 2% range. At that level, it requires a very large structure in order to create enough electricity to be viable. We'll work on trying to optimize the placement of the turbine in order to see the maximum air velocity to create the maximum amount of electricity. We'll also try to increase the temperature inside of the collector, as the change in temperature from the outside area is what also will increase the air velocity into the tower. The overall design for a greenhouse turbine generator itself isn't necessarily new. It's been around since the 70s, and then in the 80s they built a test plant in Spain. The problem they faced was the overall efficiency didn't make it cost effective. As you can see in the picture here, that tower is several hundred meters tall and very expensive to build. So without an increase in overall efficiency, to allow for either a smaller tower or for higher production, most attempts have been abandoned in creating a facility like this. We think that by using modern materials, an efficient design, including a different placement of the turbine in the tower itself, and improved materials in the collector, that we can improve the overall efficiency of the system enough to make it a viable design for electricity production.
Project scope. The overall goal of this project is to design and construct a greenhouse turbine generator. Once constructed, we will then test the position of the turbine within the tower that will achieve the best efficiency. By placing the turbine at different heights within the tower, we can see how different air velocities can maximize our efficiency. Through calculations, we have found that the efficiency increases with the height of the tower. Our tower will be limited to 15 feet in height with a 15-foot diameter collector. The tower will be 4 inches in diameter. Using these constants, we can calculate an approximate output in watts. By placing the turbine in different locations within the tower, we can test what position gives us the best efficiency and output. Below is a table showing how differences between ambient temperature and the temperature under the collector can change our output power. The goal is to get the greatest difference, and this will achieve the best output power. As you can see from the table, our efficiency does not change with greater temperature difference. But as the temperature difference is greater, our velocity going through our tower and our total output power will increase. The scope of this project includes developing the design and construction plans, acquiring all materials for the construction of the greenhouse turbine generator, installation of turbine inside the tower, installation of the greenhouse collector where heat will be collected and stored, the design and development of the turbine powered generator, construction of the greenhouse approximately 15 feet in diameter, the construction of the tower approximately 15 feet in height and 4 inches in diameter. The greenhouse turbine generator will consist of 3 parts: the base, the tower, and the turbine generator. We will construct the greenhouse turbine generator and determine the best turbine position for maximum efficiency. The electricity created will be DC power. The scope of this project does not include the commercial sale of any power. This is strictly for research and testing. The building of turbine blades, we will be using pre-manufactured blades. The building of a motor generator, and the use of a power supply to convert from DC to AC voltage.
Our group's design addresses several of the EC 2000 criterion for considerations. First one addresses the environmental. This is a clean alternative for large-scale electricity production. It doesn't have as great of impact on the environment in the long term. There's impact in the initial construction, but then the facility essentially operates on air and the heat generated by the sun. Another consideration addressed is political. This facility would be relatively easy to operate with a small staff. This would be beneficial in developing countries that don't have the luxury of a large trained workforce available. So then it could improve the infrastructure by providing electricity to areas that may not have that currently. Another consideration is the safety. This facility wouldn't use any combustible fossil fuels, so there's less risk of explosion and exposure to toxic fumes. Additionally, there are very few moving parts in this system other than the turbine attached to the generator. There isn't as much danger in the operation of this facility.
Team capabilities. The facility necessary to conduct the project will require an outdoor area with adequate access to sunlight or artificial heat lighting, approximately 15 feet in height and 15 feet in diameter. Current research indicates no special processing methods will be required based on the readily available materials selected for this project. The production will be concentrated in three main areas: the thermal collection area, the central customizable height pillar, and the turbine generator position in the pillar. The team has been divided into 4 groups, each assigned a different design aspect for the project. Special considerations were taken with group formation to account for special interests and experience. In conclusion, using already conducted research and developmental test data, Team G2G will design and construct a small-scale greenhouse turbine generator using readily available materials such as PVC, polyethylene sheeting, and a DC generator. Team G2G will incorporate modern material and a customizable shaft to create multiple different turbine test heights to determine the most efficient turbine height. The construction of the small-scale model will demonstrate this design and confirm that large-scale models will be a viable energy source.